So what I'd like to do now is go back to page 33 in our workbook and talk about coming up with an equation of a function given its graph. So have some examples here that are already worked out. So the first thing we do is kind of like before is we identify the parent function. So like this would be the absolute value function. This would be the x squared function. So the first step is to identify the parent function. This one is reflected upside down. So we do have it's reflected across the x-axis. Likewise, this one also is reflected upside down. So both of these are reflected across the x-axis. Next, we want to look to see if we've got a stretch or compression. So if I look at A here, my absolute value, if I from the bottom point or the peak, I guess in this case, if I go over 1, I'm supposed to just go down 1 on my parent function, but notice this goes down 3. So this has been stretched by a factor of 3. So we identify that. And then we got to look at the shifts. So this point originally was here. It's been shifted 5 to the right and up 6. So my vertical shift says shift 6 up, horizontal is shift 5 to the right. So when I'm putting this together, reflect across the x-axis stretch of 3, that gives me the -3 here in front of the absolute value. It's shift 5 to the right, so I have to put a -5 because it's in the opposite direction, and then +6. For this one, we already said it was shifted across the x-axis. Going from here to here, 1 over, 1 down, there's no stretch or compression. It's been shifted to the left 3 and up 2, so we have a vertical shift 2 up, horizontal 3 to the left. So I write down my parent function square function. To the left 3, I'm going to have to put this as a +3. Reflect across the x-axis, I need to put the negative here. And then it's been shifted up 2, so +2 here. Let's look at page 34. Kind of the same thing. Here we've got what looks like our square root function. It's still facing the correct direction. It's not been reflected. However, it's certainly been stretched because if I go look at my parent function, I go from here to here. Well, now I'm going from here to here. So instead of going up 1 unit, I'm going up 3. So it's been stretched by a factor of 3. This point's been shifted left 1 and down 4. So I'm shift 4 down and left 1. So I'm going to have this 3 in front of the square root. To the left 1, I have to put a +1 and down 4 -4. So this 3 is going to go here in front of the square root. Shift to the left 1, I have to write that as a +1 underneath the square root of the x, and then down 4 -4 on the outside. And then this is our absolute value function. It's not been reflected. It's been shrunk here because I'm going over 1 and only going up by 1/2, so it's vertically compressed or shrunk by a factor of 1/2. It's been shifted down 2 and to the left 3. So when I write this out, I'm going to put the half out here, the down 2 -2 out here. To the left 3, I had to put this as a +3 in the opposite direction. So now let's go to page 47. See if we can do some on our own. All right, so step 1, we've got to identify the parent function. So this is the cube root of x. And remember, the cube root, this point starts out here. So we already know it's been horizontally shifted 3. So we have a horizontal shift of 3 units to the right. And it's also been shifted vertically once. So I can skip down here and say 1 unit up. Now in terms of the shrink or stretch, when I've got my cube root function, I go 1 over and 1 up. Well, if I go 1 over, I'm going 2 up. So 1 over, I'm going 2 up. So there's a stretch of 2. So vertically stretched by a factor of 2. Now, is there a reflection? This one's a little bit tricky because you can either do it as a vertical reflection, upside down, or as a horizontal reflection. If you have the choice of doing it as a vertical reflection or horizontal reflection, do it as a vertical reflection. So we're going to do this as, there's a vertical reflection. Oh, let me do that in a different color. Let me pick on black, I guess. Okay, so now I need to put together the function. So I'm going to go ahead and write f of x equals, and my parent function was the cube root. I'm going to leave a little space here because I have to add stuff in. So my horizontal shift was 3 to the right. So I need to put that in as a minus 3. I have a vertical stretch of 2. So that 2 has to go here. There is a vertical reflection. So I need to make that 2 a negative. And then it's shifted up 1. So I have to put a plus 1 out here. And that's how I come up with my function. Let's try number 10 here. So identify the parent function. Parent function is the absolute value of x. Horizontal shift. I went 4 to the left. Alright, so has this been shrinked or stretched? Looks like we have a shrink. I'm going 1 over, but only going up a half. So it's a vertical shrink. By a factor of 1/2. In terms of reflections, there's none. Vertical shift, well, it's been shifted. If I look at my graph, it's been shifted down 2. So again, just going through, filling in my steps, and now I'm ready to build a function. Again, I'm going to leave some space here. And that's kind of grab everything. So, I forgot to put the x in there, so let me do that. Shifted 4 units left, so I have to put that as a plus 4 down here. Vertically shrink by a factor 1/2, so I have to multiply the absolute value by half. And then it's shifted down 2 units, so I need to put a minus 2 here. All right, so let's go ahead and make sure you take some time to kind of go back through these. This is kind of, I think, is the hardest part here, is to come up with the equation. So, and keep in mind, when you come up with the equation, you can test it out. Horizontal shift of 4. So I shift my absolute value to the left 4 units. I can compress it by factor 1/2, squeeze it down, and then I'm going to shift it down 2. Apply your transformations to your equation. Make sure it matches what your graph is here that you have up here. It's the way you can double check it.